The last objective in section 5.5 is factoring trinomials of the form ax squared plus bx plus c, where a is not equal to 1. Here's the method. Toby talks about a grouping number, which is just AC, the product of the first and third coefficients. Well, we have to get an AC. We have to get the number AC and then get the factors of AC. And we have to find a factor such that the sum is B. So of all the factors of AC, what we have to get the one that the pair of numbers that have a sum of B. Use those two factors to write Bx as a sum of two terms, factored by grouping. So we're going to factor this trinomial here using this method. Well, what's AC? What's the product of the first and third coefficients? Well, it's 2 times 4, or 8, correct? And then we need all the factors of 8. What are the factors of 8? Well, 1 times 8, 2 times 4. That's it. Now, we choose 1 and 8 because their product is 8 and their sum is 9, right? That's B. So that's the one we want. Because this is ax squared plus bx plus c, where b is 9. The b right here is 9, so that's why we pick 1 and 8. We choose 1 and 8. We write 9x using these two numbers, 1 and 8. 1 times 8. 1 times 8. And then we're going to factor by grouping. So we're going to go back to that method that we've learned, factor by grouping. To factor by grouping, we're going to take those 4 terms, right? That's the method that we always use when we have 4 terms and we're supposed to factor something. So we're going to factor by grouping, meaning we're going to split this right down the middle here and factor the first pair of terms and factor the second pair of terms and hope that each of those factorizations has a common factor. Well, magically it works out. 2x plus 1 is a factor of both. If we factor out the greatest common factor for the first 2 terms, giving us a 2x plus 1 on the inside of the parentheses, and we get the same thing if we factor 4 out of the second 2 terms. Well, now we're going to factor the result, right? We're going to take this 2x plus 1, which is the same as 2x plus 1, and a factor of 2x plus 1 will appear in the final factorization. What is the other factor going to be? Yes, x plus 4. The x plus 4 will appear as the other factor. Why? Because, you know, how many 2x plus 1s do we have? Factor 8x squared plus 10x minus 3. 4 of them. Well, AC x plus 4 of them. Negative 24. Now this has a lot of factors. I mean, it could be 1 times 24, could be 2 times 12, could be 3 times 8, could be 4 times 6. But actually it's this one, the 12 and the negative 2. And to make the 10, obviously we would need that 2 to be negative. And so negative 2, positive 12, those are the two numbers that are going to multiply together to make negative 24 and add together to make 10. Then we're going to rewrite 10x using these two numbers as 12x minus 2x. And so now we're going to turn our trinomial that we were given into a 4-term polynomial. We might call it a quadrinomial, and factor by grouping. So rewriting 8x squared plus 10x minus 3, we have a 12x and a minus 2x, and as we always do when we're factoring by grouping, we're going to split this thing right down the middle. Factor pairs of terms, first pair, second pair. Looks like there's a common factor there of 4x. And when we factor out a 4x, we're left with 2x plus 3. And, well, if we factor out a negative 1, we get that same 2x plus 3. So now we have two things. What's the number one rule of factoring? Factor of 2x plus 3. The number one rule of factoring is factor out the greatest common factor. And of course the other factor, and so far in this video we haven't had any greatest common factor other than 1. But of course this time we do have a greatest common factor, which is not 1, it's 3. So we factor it out, and that'll make the problem a little bit easier for us. Now we're going to use what Toby calls the grouping number method, also known as the grouping method, also known as the AC method, also known as the British method, also known as the gross product method, for factoring that trinomial. They're all the same method. Anyway, negative 30, that's what AC is, 3 times negative 10. And so we need two things. This is the way I usually write it. We need two things which multiply together to make negative 30, 3 times negative 10, and add together to make what b is, which is 1, right? Okay. Let's erase that. Let's see. I want 2 blanks there. B is 1. Okay, right? That's B right there, that 1. So, what are the two numbers? Well, it looks like 6 and negative 5 will multiply together to make negative 30 and add together to make 1. 6 and negative 5, 6 and negative 5. And so we're going to go from here, break up the middle term. Okay, so let's see. We have that factor of 3 that's always going to be there. But now we're going to break up the middle term. 3x squared plus 6x minus 5x minus 10, factored by grouping. That's a 6. Factor by grouping, factor first pair, second pair, and so out of the first pair we see 3x as a common factor. You factor that out and you have x plus 2. Out of the second pair of terms, negative 5x minus 10, negative 5 is a common factor. And when you factor that out, magically, again, x trial and error method. This is good. X plus 2. Depending on, what. Okay, so trinomial you're given. But let's see. 3 is 1 times 3. It's prime. 1 is 1 times 1. So apparently, x plus 2. We're going to need a 3x and an x. Factor the result, and then we just have to fill in the appropriate numbers. In order for the coefficient of the x squared term to be 3, the coefficients of the x terms and the factors must be 3 and 1. Got to be a 3x and an x. And so to make the 1, well, it's got to be a 1 and a 1. That's the only way to make a 1. Got to be a 1 and a 1. And of course, we will FOIL to check 3x squared plus 3x plus 1x. 3x plus 1x are 4x, which is what we need, plus 1. 9x squared minus 13x. That's our factorization. 9. Well, it's not prime. It has a couple of different factors. 1 times 9, 3 times 3. A couple of pairs of factors. Same is true of the 4. 1 times 4, 2 times 2. We have to come up with, the right combination that works. Generally, what works the best for us is to start at the bottom and go up. Start at the bottom and go up. And so we're going to start out by saying, okay, let's try a 3x and a 3x. We're trying to, create a pair of binomials which, when multiplied, results also in negative 13x. Well, if we start at the bottom, go up, 2 and a 2, the signs, of course, will have to be both negative in order to create a negative coefficient of x and positive 4 that we need. But when we give this a trial here, what do we get? We know we have the 9x squared that we need, and we know we're going to have the 4. The only question is about the middle term. What do we have? Well, negative 6x, another negative 6x. That's close to 13x, but it's actually just minus 12x, which isn't quite the right thing. And then plus 4. Which is, again, 9x squared minus 12x plus 4. That's not the right thing. We need a minus 13x. Well, we could try 3x and a 3x again, and maybe try the 1 and the 4, and who knows, maybe that would give us the right factorization. So let's see, a 3x and a 3x a 1 and a 4. And of course, to make the positive 4, we will again need both numbers to be negative. Well, we're not going to waste our time foiling the whole thing here. We only are interested in, we're not interested in the first term and the last term. We're interested in the two middle terms. Okay? So basically, in FOIL, if the product of the first terms, we know that we got that right, 9x squared, because we're only going to try 3x and a 3x, or a 1x and a 9x. Outsides and insides, that's what matters, because the product of the last terms also does not matter. We know we're going to get that right, because we've already decided we're only going to put under trial here the 1 and the 4 and the 2 and the 2. So middle term, what are we going to get for this one? Well, we're going to get, outsides is minus 12x. Okay, minus 12x minus 3x. So that's negative 15x. And that's not going to get it done either. So apparently it was not the 3x and the 3x after all. Apparently it's the 1x and a 9x, or a 9x and a 1x. Well, we'll try the 2 and the 2. So minus 2 minus 2. And outsides is negative 18x. Insides is negative 2x. That's not going to get it done. That's a minus 20x. Let's try the, well, obviously we have to try the 9x and the x with the 1 and the 4. Of course, there are two different ways to do that. We might anticipate a little bit, kind of mentally figure out, how we think this is going to go. And so if we did that, we probably would avoid the 1 and the 4, because I don't think we're going to be able to make a negative 13x for our middle term if we went 1 and 4. So let's try 4 and 1. Minus 4 minus 1. We FOIL, and we're going to get 9x squared minus 4x minus 9x. That's what we want, plus 4. And so that is going to be the correct factorization. 9x squared. This is checking, right? It's a check. We have what we think is an answer there in blue. We think that's the answer, but we're just checking it by foiling. And that's what we do in factoring. We check by foiling. 9x squared. Product of the outsides is negative 9x. Product of the insides is negative 4x. Product of the last terms is 4. Combine the two middle terms to make the negative 13x. So our factorization checks. Check. And so the answer is this 9x minus 4, 5x squared plus 2x minus 7x minus 1. That's a prime number, as is the 7, 1 and a 7. It's got to be a 5x and an x. 5x and an x and 1 and a 7. Could be 1 and a 7, could be a 7 and a 1. Could be positive and a negative, could be a negative and a positive. We know the signs are going to be different because we have to create a negative product. And of course the test will be to create this positive 2 here. So if we have different signs, we might go 1 and 7, we might go 7 and 1. It seems that maybe the 1 and the 7 with a positive and a negative will get it done. If we FOIL, we have 5x squared. Oh, that's not it. That's not it at all. Okay, so just to prove that we are still using trial and error, what we get out of this is 5x squared minus 35x plus x minus 7, which is 5x squared minus 34x minus 7. So no, that's not it. And so we go to still a 5x and an x and a 1 and a 7, but we're either going to switch the signs or we're going to switch the numbers. Let's keep the 1 and the 7 and go negative and a positive. And again, all that matters is whether the middle works out for us. And in the middle, well, that's not going to work out. 35x minus 1x, that's a 34x. So work, 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 that's going to be a no. 5x and an x. Okay, so the next trial. 1 and 7 is just not happening. 7 and 1. And I believe with a plus and a minus, we're going to be good. So to verify, five x squared minus minus 5x plus 7x minus 7. It's going to get it done because we will combine these two to get 2x, the elusive 2x that we've been trying to get this whole time. 5x squared plus 2x minus 7. So our answer is 5x plus 7, x minus 1.